To solve this equation, we want to get x by itself. And notice we have a number 5 in front of x, which means 5 times x. And we also have a plus 7 after 5 times x. So we need to get rid of both of these two numbers so we can get x by itself. Now, first we want to get rid of plus 7. And in order to get rid of plus 7, we can do the opposite operation. So again, imagine you have $7 credit, and if you want to get rid of it, you will spend it. So we subtract 7 from the left-hand side. And the right-hand side, we also have to subtract 7 because in order to keep the scale balanced, imagine the equation being a balanced scale, we have to make sure we do the same operations to both sides. So now the left-hand side, the plus 7 and the minus 7, they cancel out. So we only have 5x left. On the right-hand side, we had 2 minus 7. So that's going to leave us negative 5. And then we can divide both sides by 5 to get rid of 5 because the operation between 5 and x is multiplication. So in order to get rid of 5, we can divide both sides by 5, and after we cancel 5 and 5, we're going to left with x. Again, because we have 5x, in order to get rid of the 5, we cannot subtract 5, and because this is multiplication here, and also 5x and 5, they are not like terms, so we will not be able to get rid of 5. They cannot be simplified. But we can do division, and which is the opposite of multiplication, and to get rid of the 5. Technically, after we divide both sides by 5, and 5 divided by 5 will give us a 1. So there should be a 1 in front of x, but anything times 1 is itself. So now we can just get rid of the 1, and now we have x by itself. Now let's look at another example. So in this example, we want to get x by itself. So notice that there is a minus 4 and there is a negative 3 times x. So we want to get rid of both numbers. So first, we're going to get rid of minus 4. And we do opposite of that, which is adding 4. So imagine if we owe somebody $4 or we have $4 in debt, we're going to have to add money to that account in order to balance it out. So after that, we have 0 because negative 4 plus 4 will give us 0. So technically we have a plus 0 here, but anything plus 0 is itself, so we can just get rid of plus 0. So we bring down negative 3x, and on the right hand side, after we add 4 to negative 10, we get negative 6. So now we can get rid of the number negative 3 in front of x. And notice between negative 3 and x, the operation is multiplication. So we will use the opposite of multiplication, which is division, to get rid of negative 3. So we divide negative 3 both sides. And notice that negative 3 divided by negative 3 will give us a 1. Again, 1 can be omitted. So we have x equals the negative divided by negative is positive, and the 6 divided by 3 is 2. So now we can get x by itself. Now just a little bit of explanation here. In both examples, we chose to get rid of plus 7 and to do instead of, so for example, in this example, we didn't get rid of 5 first. Why didn't we do that? If we want to get rid of 5, we can, but because whatever operation we do to the left-hand side, we also do the same thing to the right-hand side. And also, the operation must be done to the entire left-hand side, which means we have to take the both terms, 5x and 7, and divide by 5. And notice that this is gonna turn in the whole numbers into a lot of fractions. And this will work. So when we do divide the left-hand side, because there are two terms, so we have to divide 5x by 5. We also have to divide 7 by 5. Again, everything on the left-hand side and everything on the right-hand side must be divided by 5. And notice 5 cancels 5 here, and we almost get x by itself. We did get rid of the number 5 in front of x, but we also created a lot of fractions. So next step, we will have to get rid of this fraction here, and we try to avoid fractions if it's possible. And this will still give us the correct answer because positive 7/5, in order to get rid of it, we need to do the opposite. So we do minus 7/5, so they cancel each out. And we have x on the left-hand side and on the right-hand side. In order to subtract the fractions, we keep the common denominator 5, and we do 2 minus 7, which give us -5. And -5 divided by 5 will still give us -1. So although we get the same answer, as you can see from the steps, this is much more complicated than getting rid of +7. Because when we try to subtract the 7 from the left-hand side, these two are like terms, so we can cancel them, and really it doesn't really affect 5x. But if we divide the left-hand side by 5, we have to divide both of them by 5, not only just this 5x, because the left-hand side has both 5x and a +7, and that will create a bunch of fractions. So that's why we choose to get rid of 7 first, and then to get rid of so 7. Imagine 7 is sort of further away from 5x, and in the order of operations, please excuse my dear Aunt Sally. And we know multiplication has a higher priority than addition or subtraction, so they are sort of like bonded together. So we will get rid of the not so close one, +7, and then we get rid of 5. And similarly, that's why in this second example, we chose to get rid of -4, because there's multiplication between them. They're closer together. Again, if we choose to get rid of -3, you will have to divide both of these by -3, and which creates fractions. It will still give you the correct answer, but it's harder.